Bismillahirrahmanirrahim. Now we are starting this new session, and in the last session we completed the method of finding the complementary function for the homogeneous higher order PDEs. So now it's time to write few practice problems for you. So you have few problems for applying the same method. So now I am writing few examples just for your practice. So the few examples are practice problems These practice problems include number 1, partial 2z over partial x square plus 4 partial 2z over partial x partial y minus 5 partial 2z over partial y square equal to 0. Number 2, d cube minus 6d square into d dash plus 11d into d dash square minus 6d dash cube of z equal to 0. Then number 3, partial 4z upon partial x power 4 plus partial 4z partial y power 4 equal to 0. Then number 4, we have 2 partial 2z over partial x square plus 5 partial 2z over partial x partial y plus 2 partial 2z over partial y square equal to 0. Then number 5, d cube minus 6d square into d dash plus 12d into d dash square minus 8d dash cube of z equal to 0. Then number 6, partial 2z over partial x square minus 4 partial 2z over partial x partial y plus 4 partial 2z over partial y square equal to 0. I have written 6 examples for you. This is the second order homogeneous higher order PD, the third order, the fourth order, second order, third order, second order. So it will provide you enough practice for finding the solution of these higher order homogeneous PDEs. Now it's time to start the solution of higher order PDEs when right hand side is given as non-zero value. So if you remember, we discussed in higher order ODEs that 5 different methods for the non-zero terms appearing on the right hand side. So following the same pattern in higher order PDEs, when the right hand side will be non-zero, we will discuss almost in the same style 5 different methods. So starting with the simplest one, that is exponential. If you remember, we started with exponential term in higher order ODEs as well. So I am following the same pattern here, and I will apply the same technique for the method. So methods to find particular integral in homogeneous higher order PDE. So method 1 is relating to when function of xy means right hand side of the equation which I said the standard form of higher order homogeneous PDE. So when fxy is equal to exponential e power ax plus by. So let me give you now the way to solve that one. So let's say we have an example that partial 3z over partial x cube minus 3 partial 3z over partial x square partial y plus 4 partial 3z over partial y cube equal to e power x minus y. Let's say we have on the right hand side exponential, and exponential means we have the same thing x. Let me start with positive x plus 2y. Then I will use minus in between them. So what is the way to solve this one? So the actual way to solve this one is to start with writing in operator d form. So this will be d cube minus 3d square into d dash and plus 4d dash cube of z equal to e power x plus 2y. Now the question is in its operator d form. Then you need to write, you said this is equation 1. Now you need to write the auxiliary equation, that is m cube minus 3m square into 1 plus 4 into 1 cube equal to 0, or m cube minus 3m square plus 4 equal to 0. This is the auxiliary equation of this equation. Then what you need to do is to find the roots. So for me the roots of this equation will be 2. Yes, one root will be 2. So if one root is 2, then other roots will be let me check other roots will be, because one root will be 2 and other roots will be, let me calculate because I do not have calculator at this time. So m cube minus 3m square plus 4, m2 means m minus 2. So m square m cube minus 2m square plus minus, so minus m square plus 4. So minus m, so minus m square minus 2m plus, so 2m plus 4, so plus 2. M cube minus 2m square, m cube minus 2m square, so plus minus m square plus 4. So then minus m, so minus m square plus 2m. So it will be minus 2m, so minus 2 minus 2m plus 4. n square minus n minus 2, it simply means that the roots will be in complex number form. Other two roots will be. So then other two roots will be n equal to 1 plus minus under root 1 minus plus 4 to the 8 upon 2. So n is equal to 1 plus minus 3 upon 2 minus 1 minus 1. Yes, one root will be minus 1 and 2. So these are the roots. 2 is the repeated root and minus 1 is also a root. Means minus 1, 2 and 2 are the roots of this equation. Hence ZC. Just like we did in ODE, that if you need to find the particular integral, then represent C as is subscript to show that this is the value of the complementary function. So it means f1 y minus 1 into x plus f2 y plus 2x and plus x f3 y plus 2x. I am solving this example right from start to end, and then from onward I just find a particular integral. So this is the complementary function of this example, and now we are moving to, this is the complementary function, and now we are moving to particular integral. So particular integral means Zp will be equal to, from equation 1, Zp will be equal to 1 upon d cube minus 3d square into d dash and plus 4 d dash cube applying on e power x plus 2y. This will be e power x plus 2y. So now here substitute d is equal to 1, d dash is equal to 2. How I get this? Just equate given e power x plus 2y with this. So if you equate these one, the coefficient of x will be known as a and the coefficient of y will be known as b. So here if you look at coefficient of x is 1, so a is equal to 1 and b is equal to 2. So if I write in this way, that a is equal to 1 will be placed on the position of d and b is equal to 2 will be placed on d dash. So substitute these values, we will get Zp is equal to 1 upon 1 cube minus 3 into 1 square into 2 and plus 4 into 2 cube e power x plus 2y. So if I simplify, this will be 1 minus 6 plus 32 e power x plus 2y, means final answer will be 1 upon 27 e power x plus 2y. As we are calling in higher order ODE, that if the denominator is non-zero, then this will be the answer. So this is the answer of the particular integral, hence writing the final answer, that is z equal to zc plus zp. So z equal to zc was f1 y minus 1 into x plus f2 y plus 2 into x plus x f3 y plus 2 into x and plus 1 upon 27 e power x plus 2y. I solved this example from right start to end. But from now onward, as we did practice this thing in higher order ODE, that I will not discuss this portion, neither I will discuss this portion. We will only be focused on particular integral. From now onwards, our focus is only on this portion. Which I circled as blue circle, that we will only focus on this portion, means we just focused on working on particular integral, because this is the way to find complementary function. We did it in the previous session and now you have practice problems as well, and these examples will also be included. Whenever we give an example of particular integral, that example will also be added in the examples of complementary function, because I told you that when you need to find an example whose right hand side is non-zero, it means you need to find both complementary function and particular integral. It is mandatory to find complementary function in all cases where right hand side is non-zero. We need to do it by default. So you need to do this part, and then the representation of the final answer, that write z equal to zc plus zp. So just to save the time, again I will only be focused on this portion and leave these two things on you in each and every example which we will do in future. So now I am going to do another example. So we have the idea of more examples again and again. Let's have another example. So this is example number 2. Let's suppose we have d square minus 2d d dash plus 3d dash square of z equal to e power x minus y. Let's say if we have to do in this way, then 1 minus 2, 3 if I do in this way, then we will move into another phase. I want to make this example to show when the denominator becomes 0, then what we need to do. Now I hope the denominator will be 0. Yes. So now I am calculating ZP. ZP means 1 upon d square plus 2d into d dash minus 3d dash square e power x plus 1. So here a is equal to 1 means d is equal to 1, d is equal to 1 means d dash equal to 1. Therefore, Zp will be equal to 1 upon 1 square plus 2 into 1 into 1 minus 3 into 1 square. And look now, exactly the denominator is 0. Now the denominator is 0. Since denominator is 0, if you remember what we did in higher order ODE. In higher order ODE, we said we need to differentiate it by writing for x and then 1 upon 2d plus 2d dash e power x plus y. I am doing exactly in the same manner as I did in higher order ODE, that if the denominator is 0, then you need to differentiate the given thing. So now again it's time to resubstitute the value. It means 1 upon 2 into 1 plus 2 into 1 e power x plus y. It means I have x upon 4 e power x plus y. So the same idea we have as we have in higher order ODE method 1. This is almost the same method 1 as we worked in higher order ODE. Almost, I think almost 90% both methods have the similarity. Now let's have one more example with a negative sign in between them. That what will be the scenario when we have a negative sign in between them? Let's say we have an example number 3 means partial 3z over partial x cube minus 2 partial 3z over partial x square partial y equal to e power 2x minus y. Let's suppose I have this thing as an example. So what we need to do for is first to write in operator d form. So this is d cube minus 2d square into d dash of z equal to e power 2x minus y. So this becomes equation 1. Now for particular integral we will write 1 upon d cube minus 2d square into d dash e power 2x minus y. Now here a is equal to 2 means the value of d is 2 and b is equal to minus 1 means d dash is minus 1. So substituting this, zp will be equal to 1 upon 2 cube minus 2 into 2 square into minus 1 and then e power 2x minus y. So this becomes 1 upon 2 to the 4, 4 to the 8, 2 to the 4, 4 to the 8 minus plus 1 upon 16 e power 2x minus 1. So if you have a minus sign in between, it means the value of b is with negative sign. So this is the way to use for method number 1, that is when exponential is given on the right hand side. So now let me start with the method number 2, that is when we have examples like complementary function and other things. So let me give you idea about method number 2. So now we are starting with method number 2. If you remember, we discussed method 2 in higher order ODE, and we said that method 2 is relating to only method 2, means when fxy is equal to sine ax plus by or cos ax plus by. Sine ax plus by or cos ax plus by means only linear sine and linear cos will be treated in this method. And if you remember, the same thing applied in ODE as well. In ODE, we said that in method 2 only linear sine and linear cos will be treated in this. So considering an example, example 1. Let's say we have this example, partial x square partial y plus 4 partial 3z over partial x partial y square equal to sine 2x plus 3y. Let's have an example like this one. Then we will apply the method here in operator D form. This is d cube minus 4 d square into d dash plus 4 d dash cube of z equal to sine 2x plus 3y. Now for particular integral, we need to write zp is equal to 1 upon d cube minus 4d square into d dash and plus 4d dash cube of sine 2x plus 3y. Here a is equal to 2, b is equal to 3, so this becomes the value of b and b dash. Now the most important thing, that is what value will be replaced in this method. In method 2, d square will be replaced by minus a square, as we did in higher order OD as well. But other thing, d dash square will be replaced by this, and d into d dash will be replaced by minus a. So only these three values can be replaced, neither less nor more. We need to only replace these values. So okay, working on this example, this is equal to 1 upon d cube means breaking d into d square, as we did in higher order OD as well. Then minus 4d square d dash and then plus 4d dash square into d dash. So I am just breaking here, not substituting the values. Now I will substitute the values here. So now substituting the values means Zp is equal to 1 upon d and in place of b square I need to substitute minus a square, and the value of a is 2, so minus 2 square. Remember, this square is not on the value of a. This minus is not on the value of a. Then secondly, minus 4d square means minus a square, then into d dash, then plus 4. B dash square means minus b square, b is 3, into d dash. So now we have sine 2x plus 3y. Now simplify 1 upon, this will become minus 4d, this will become minus plus 16d dash, and this will become minus 36d dash. Sine 2x plus 3y. Simplifying more, 1 upon minus 4d will minus 20 d dash sine 2x plus 3y. Minus 36 plus 16 is minus 20. Simplifying one more step, minus 4 is common in this, so d plus 5d dash sine 2x plus 3y. Now from here, if you remember what we did in higher order ODE, because we are only allowed to substitute the values of quadratic d and no d is quadratic here, so we need to make it quadratic by rationalizing. So this is 1 upon minus 4. I write d minus 5d dash in numerator, so it will become d square minus 25d dash square sine 2x plus 3y. So now we have 1 upon minus 4. In denominator we write minus a square minus 25 and minus b square. In numerator, d minus 5d dash will be applied on sine 2x plus 3y. Since the time is over for this session, so I am ending here, and inshallah we will continue from this step in the next session.